Back. I'm going to give you another sequence, and the sequence will read 3, 2, and 4 over 3. Right? So those are the terms of the sequence. Now, as you know, I'm dealing with a section on geometric sequences. It is also possible for this to be arithmetic, maybe, but it's up to you to test the sequence, right? So when we test the sequence, we see if we can find a D. Okay, let me just give you the questions. I want you to determine which term of the sequence is equal to 128 over 729. That's what I want. Okay, so as you know, this here is T1, that's T2, that's T3, that's Tn, right? It's some unknown n which we want to find. This here corresponds to n equals 1, n equals 2, n equals 3, and this here corresponds to some n that we have to ultimately solve for. And remember, because n is a position, sorry about that, remember because n is a position, we need to be able to find a whole number, like first, second, third, 1, 2, 3, 4, etc., right? Okay, so before we continue, there's two steps to being able to solve this. One is you need to identify the case, right? Because the sequence is given, I've got 3, 2, and 4 over 3. The sequence is given. Sequence is given. I've got a given sequence, so that means that this is going to be a case 1 example. Okay, so clearly this question is case 1, right? It's case 1. It's case 1 because the sequence is given. Now, we need to test the sequence. Is this arithmetic? Well, for it to be arithmetic means if I take 2 minus 3, I get negative 1, and if I take 4 over 3 minus 2, and 4 over 3 is 1 and 1/3, it leaves me with negative 2/3. It's definitely not arithmetic. When I take T3 minus T2 and I take T2 minus T1, this is not arithmetic. So I'm going to erase that quickly. So this is not valid, right? So we need to check, is it geometric? Well, let's check, is it geometric? Let me take T3 divided by T2. And that's going to be 4 over 3 divided by 2, which is the same as saying 4 over 3 multiplied by 1 over 2. And 4 divided by 2 is 2, so this here gives me 2 over 3. If you're unsure about this, just do it on the calculator for now, if you're allowed calculators in your examination. So let me take T2 divided by T1. T2 is simply 2, and T1 is simply 3. And now I've got that, and I've got that, and I notice that there is a constant ratio. So clearly the sequence is geometric. Now, as the video suggests, I'm going to deal with the geometric sequence, which means you should have already known it's geometric. However, it's always good to test the sequence, right? So let us go and do this question now. 3, 2, and 4 over 3. And we want to know what is equal to 128 over 729. Okay. Which n does this represent? N equals question mark over there. This one is n equals 1. It's the term value in position 1. This is n equals 2, which is the term value in position 2. And this is n equals 3, term value in position 3. Okay. In all these cases, you need to first find the general formula. And once you've found the general formula, then you can do direct application of the questions in terms of the general formula, right? So let's write down the general formula, which is Tn equals A. A is going to be 3. I'm just going to write it out in full for now, AR to the n minus 1. We've solved for R, where we said R is equal to 2 over 3 in the previous slide. So that's 3 times by 2 over 3 to the power of n minus 1. Now, we are given here the term value. We're given the term value. We're given Tn. We're going to solve for this n, right? So what does Tn equal? Well, Tn is going to be 128 over 729 is equal to 3 multiplied by 2 over 3 raised to the n minus 1. This is one equation with only one unknown, and that now means that it's solvable, right? Firstly, let's get rid of this 3. I divide by 3 on this side, which is the same as saying let's multiply by a third, right? And if I've multiplied by a third on one side, I've got to multiply by a third on the other side. So that cancels that over there, and I'm left with just 2 over 3 to the n minus 1. So I'm going to put that over there, 2 over 3 to the power of n minus 1. Now I've got a fraction times a fraction, which just means I multiply the tops with the top and the bottom with the bottom, and that leaves me with 128 over 3 times 729, and that's going to give me 2,100 plus 60 plus 27 is 2,187. Okay, now what happens when you get an equation like this at this point? Well, let's continue further on this side. Switch colors here briefly. You got to express this in terms of a power of 2, right? We want to get the bases the same, and we want to express the denominator as a power of 3. So let's express the top 2 to the power of 7 is equal to 128, and just for interest's sake, 3 to the power of 7 is equal to 2,187. And you could have done this on the calculator just by playing around with powers of 2 and powers of 3. And 3 to the power of 7 is equal to 2,187. This is just the value of 2187 is 3 to the 7, and 128 is just the value of 2 to the 7. And then that there is equal to 2 over 3 to the power of n minus 1. At this point, you can simply say that that is 2 over 3 to the power of 7, because you can just put this in a bracket using your exponent laws, and we've got 2 over 3 over here to the power of n minus 1. Therefore, we can drop the bases now at this point, right? And we can say that 7 is equal to n minus 1, and therefore n is equal to 8. Right. And what you can do now is take this 8, substitute it in there, and then you can double check on your calculator if you get 128 over 729. And there we go.